Okay, hello. In this video, we're going to look at the idea of generalizing. In particular, we're trying to apply this to understanding the ideas of current and voltage. But the big idea behind this is generalizing something. So in the idea of generalizing, we start with some idea. And we're trying to kind of push that idea out a little bit to expand the domain that it can work on. Okay, so the idea that I want to start with is measuring the amount of flow of water along a river. So this is my water flowing through here, and this arrow here represents the flow of water. So when measuring the flow of water, we might think, all right, how are we going to measure this? What units are we going to use? And so think for a second what units you might use for measuring the flow rate of the water. All right, so I think you might have come up with a couple. You might have come up with kilograms per second, kind of the mass of water per time. You might have come up with gallons per second, a volume per time. You might have come up with meters cubed per second. That would also be a volume. What we want to do is now we want to try to generalize this idea of a current to, instead of just limiting it to the flow of water, how about the flow of anything? So maybe the flow of cars could also be a current of some sort. So maybe we have a flow of railroad cars. So I've got some train track, and I've got some train cars coming down the track. First, try to pick some kind of unit, and maybe you pick train cars per second. And that also, note, it could be the flow of, very similar, you could extend this to the idea of flow of cars down a road. These would all be examples of current. And how about for what we want to do? We want to have the flow of charge. So I've got some wire and I want to measure how much charge is moving through it. So I'm trying to measure also a current, not a water current, not a car current, but something else. So what's that unit going to be? Well, I think it'll be the unit of charge, which is a coulomb, per some unit of time second. So 1 coulomb per 1 second is also called an amp, so current. Now some of the ideas here are the same. So if you were to calculate the amount of current by taking into account the velocity and the cross-sectional area of that water, you could come up with some formula for the amount of current, and maybe we could use a similar idea for coming up with a formula for the amount of current for a wire that has to do with the velocity of the charge, average velocity of the charges, and the cross-sectional area of the wire. So could you do that? Yes. Would that be right in line with what we're trying to do here with generalizing? Yes. Is that what I want to do right now? No. So here I just wanted to connect this idea of electrical current to other currents that you might have. So think